Mixtract is a music design support system that generates natural performance expressions based on professional performances and allows users to customize these expressions to their liking. The main focus of the system is in the phrasing expression. Mixtract constructs the hierarchical phrase structure in a piece. Each phrase unit has markers to indicate parameters of performance expressions, created by the user. The parameters can be extracted from an existing performance database. In performance rendering system, digitizing and archiving excellent performances into a database are very important. We collect professional music performances, extract the expression information of these performances into a database, and make it available to the public. Hashida and others have organized a series of performance rendering competition for evaluating systems' algorithm and generated performances. The ICMPC Raincon, held in summer of 2008, had the contestant systems generate musical expressions to 2 new pieces, which were given on-site at the venue. I believe that the computer system for music expression should be developed for people who enjoy music through listening, performing, easily customizing music, creating their own expression as they desire, understanding music structures more deeply, teaching and communicating with others. I hope that my projects will be developed into a community where one can express oneself through imitating or mimicking and studying music. Even those who have little skill and experiences in music performances and conducting can generate expressive performances as a virtuoso. The next video shows the performance interfaces that make such a dream come true. We are now constructing 2 types of conducting interfaces that people can use to enjoy music conducting experience. I am now developing a performance system called IFP-MJ, which is based on IFP. The user of the system can conduct the music data converted from virtuoso performances. I am a music student, so I would like to improve the system to satisfy musicians' needs. The system which I am developing is a conducting interface for acoustic signals. This system utilizes a harmonic part and an inharmonic part of the music derived from acoustic signals. This results in rendering less noise sound, especially when the user wants to slow down the tempi of the original music. We would like to develop these systems more, as they can be used as an active music listening tool and for entertaining people. Vocal Listener is an automatic parameter estimation system for singing synthesis by mimicking user singing. To improve naturalness of the synthesized singing or to synthesize according to user preference, previous systems have focused on the manual adjustment of the parameters. However, this requires time and effort. Consequently, I'd like to develop a system that can project the nuance of a real singing to the synthesized singing. Vocal Listener estimates the parameters by iterative estimation. This way, the synthesized singing will become closer to the user singing. In addition, Vocal Listener can adjust the singing skills and can change the pitch or the singing style of the singing synthesis. I'd like to discover the nature of singing by using Vocal Listener. Signal processing is a pervasive infrastructure of applications introduced in this video. Sounds and movies are essential signals. Virtually no media equipment operates without signal processing. For example, graphic equalizers and sound effect devices are common in sound manipulations. I am somewhat critical of these existing methods. In short, the design priority was set on the efficient use of the machines. It is because machines were not very powerful decades ago. However, the exponential growth of computational power made this priority obsolete. The most expensive resource is now humans. Computational power is no longer the bottleneck. Each individual with one's unique personality, taste and talent emerging out of his or her developmental history is the most precious resource now. Every singing voice, for example, is a unique treasure because of this. Morphing is an interesting signal processing technique which can produce various types of intermediate singers that never existed before, for example by blending your favorite singer's singing style and your voice. Synthesizing a new singing voice by first separating the singing style and the voice characteristics from each of two singing voices, then blending these four factors together is what we call singing morphing. An intuitive interface for this system is also being developed. Recently, a system to synthesize singing voice from text has been developed, but it is not easy to synthesize natural singing voices. I wanted to synthesize a natural singing voice easily by using a voice morphing technology. These are the two singers singing voices. As you can see, the interactive and real-time control were examined. I want to create an easy-to-use interface by developing a singing synthesizer with advanced features such as vibrato and a technology to transform my singing style into that of a professional. CrestMuse Project aims to develop technologies to assist in the production of music contents and to provide music interfaces that can entertain people, based on investigation of design processes and on studies on signal processing and mathematical science. In this video, we introduce some results of the first half of the project, featuring musical interfaces. We would like to continue our research project as we can contribute in fostering our culture involving expression. One's dream in engaging playing, producing, and enjoying music. To realize that dream as a real research outcome. That is CrestMuse Project's goal. How about imagining the future interfaces for music? You might discover a secret pleasure of music.